Okay, hello, my name is Andres Marty. I'm an editor at Key Curriculum Press, and today's webinar is a slippery slope connecting the Common Core and slope. And today's presenter is Elizabeth DeCarli, who's also an editor at Key Curriculum Press. I'm going to go ahead and hand off control to her right now, and we will start. So thank you again for joining us, and enjoy the webinar. All right, so Elizabeth, I think I've given you control of the screen.
Okay, and can you see my screen now?
I can.
Okay, great. Oh, we have an aloha, so maybe we have a visitor from Hawaii. So I'm Elizabeth DeCarli, and I will be your presenter today. And welcome to our webinar. Thanks for coming. Today we have me presenting. Andres, he's not that blurry in real life. I just don't have a very good quality photo of him in my sketch. Sorry, Andres. And Karen Greenhouse and Andres will be answering questions in the chat panel. I try to keep an eye on the chat panel while I'm doing the presentation. We'll see how I do with that. I'm sure I'll miss a lot of questions and comments, and Andres will let me know when he wants me to answer something out loud. But because I forgot to create some polls ahead of time, I'm going to actually ask you some questions and have you answer right in the chat panel. And I'm actually going to use the chat panel kind of my way of getting responses from you all. Just as in a classroom I would ask students, out loud. I really need kind of the feedback to see if, what you're thinking about the presentation, about the sketches, and about the models. So this webinar called The Slippery Slope, we're really looking at kind of pre-slope concepts in the Common Core State Standards. There's a cluster of standards in grade 7 that focus on this concept, analyze proportional relationships, and use them to solve real-world and mathematical problems. Okay, so here we don't even have the word slope. It's just about proportional relationships. And in grade 8, understand the connections between proportional relationships, lines, and linear equations. I think in this group of standards, the word slope is introduced. So we'll be focusing on kind of middle school level activities. And I actually wanted to start by finding out a little bit about you to see. I have a question about my volume. Let me see if I can. How is this? Let me know if I'm loud enough. It's always hard to get it just right. Okay, great. So I'd like to ask you all to just respond in the chat panel. Just could you write down what level you primarily teach? So middle school, high school, some of you may be teacher educators. If you're in India, middle school is like ages 12 to 14, 11 to 14, a lot of high school teachers. 6th grade to Algebra 1, okay, high school, middle school. Oh. Oh. Okay. Great. Do we have any teacher educators in the crew, post-secondary? So I'm wondering if that's teacher educator. Great. Okay, good. And Karen just sent me a sneaky message that she actually added a poll. So I'm going to ask the second question through the polling resource. And that question is, do you have access to an interactive whiteboard? So go ahead and respond in the quick poll to that one. You should see a quick poll on your screen, and please select yes or no, but I will soon, or no, and then we'll get a tally up. Oh, yeah. Okay, yes. We're at almost 92% voted. That looks pretty good. So the results of the quick poll say that almost 70% of you have one, and another 14% will soon. Okay, so about a little over 80% of you have one or will soon, and another 18% don't. Okay, good to know. I am going to try during the webinar to give a couple of tips about ways in which you might change a sketch to make it a little bit more compatible with an interactive whiteboard, and the same tips will go for a projector if you have a projector that you use in your teaching. And I also just wanted to ask one question. If you are, oops, I should probably end this one. I didn't prepare this question ahead of time, but in the chat panel, if any of you are brand new to Sketchpad, maybe you've seen it before, but you've never used it, could you just say in the chat panel, new to Sketchpad or new, so I know that we have any new users out there. So again, if you could just use the chat panel to let me know. New to Sketchpad 5, okay, good to know. Anyone else new to Sketchpad or new to Sketchpad 5? New to Sketchpad 5, new to 5, new. Okay, good. Okay, fantastic. All right, that's great to know. Thanks so much for responding. So I will try to pause frequently for questions. Let me know if there's something that you didn't understand or that you need to see more slowly. And I'm just showing a tiny fraction of what Sketchpad can do today. So at the end, I'll give you some resources for how you can explore further. All right, and I think I'm going to go ahead and get started now. So California budget has been in crisis for years now, and I know the same thing is going on in other states. So a lot of schools nowadays kind of have fundraisers just to get basic things like music classes and art classes going. They'll have fundraisers, and sometimes we have to do bake sales for these. So the following activity is kind of based on that idea. So in this activity, we're going to be talking about a club that is making and selling popcorn balls for a fundraiser. And it occurred to me that we might have some folks that don't know what popcorn balls are because they're probably kind of an American treat. So I thought I would give a little visual description of how you make popcorn balls. And you start with some raw popcorn, pop it up. And on the stove, you make a sweet syrup. And you mix that syrup with your cooked popcorn and shape it into balls, and then you get delicious, sweet and crunchy popcorn balls. So this is what popcorn balls are. And in my context here, the math club is going to make popcorn balls for a fundraiser to make money. And in their recipe for popcorn balls, 1 cup of uncooked popcorn, wow, that is a tongue twister, 1 cup of uncooked popcorn will make 4 popcorn balls. And the question that we want to answer is how many cups of raw popcorn will we need to make 10 popcorn balls, or 20, or 140, or however many we need to sell to make enough to go on our math club field trip. Okay, so I've got a graphing environment here, and I've gone ahead and just pasted a table into my graph so that we can kind of look at a graph and a table at the same time. I'd have students would have a worksheet with a table on it so they could fill it out by hand. If I were working at an interactive whiteboard, I could use this marker tool, but I'm not very coordinated with the mouse and the marker tool, so I'm actually going to use the text tool to complete this table. And a reminder again, for every 1 cup of uncooked popcorn, I can make 4 popcorn balls. So 1 cup of raw popcorn, 4 popcorn balls. And I'd ask students to fill the rest out. And I'm going to just go ahead and do that using the text tool. Hopefully I won't make any mistakes. I'm sure you'll let me know if I do. And a question that I might ask students is, what patterns do you notice in the table? And I think, one pattern that students will probably notice first is that each number in the right-hand column is 4 times the number to its left. So 1 times 4 is 4, 2 times 4 is 8. I'm wondering if there are any other patterns in the table that you notice. So could you, in the chat panel, could you, oh, now I've just glanced over it. Sorry, we're not going to be including actual popcorn balls with your email this time. That will be that'll be for next time. Could you let me know, do you see any table patterns, any patterns in the table besides the times 4 pattern? Look at the table and see if you observe any other patterns, and if you do, please write me a note in the chat panel. Oh, okay. Okay. So this is interesting. So you saw 4 is doubling to 8, is doubling to 16, is doubling to 32. And it's interesting because our raw popcorn, we're counting up doubling as well, right? 1 doubles to 2, 2 doubles to 4, 4 doubles to 8. Santita noticed that these are powers of 2. And input and output are doubling each time. Great. So those are great observations. And Raylan says, my kids always see the vertical pattern first rather than the horizontal pattern. Yeah, I think that was true of my students as well. They looked at the patterns between these numbers, and that's okay. You know, it's a good observation. We do want students looking for patterns in math, right? That's always one of my goals. Great. So I'm going to go ahead and graph, and I want to show, for those new to Sketchpad, I want to show the difference between plotting a point and constructing a point. If I construct a point just by using my point tool, I've constructed a point in space here on my coordinate grid, and I can actually drag that point around freely anywhere. Okay, so that point isn't tied to anything. If I construct a point on an axis, then that point is going to be restricted to the axis. So I will only be able to drag it along the axis. For the purpose of this activity, I actually want the points to stick to these coordinates. And so I'm going to use a plot points command instead of just constructing a point. Okay, so I'm going to delete these 2 points. And then I'm going to go ahead and use the plot points command. And I'm just entering numbers in my keyboard right now. So 1, 4, 2, 8, 4, 16, and 8, 32. Now, I can see 3 of the points that I plotted, but I'm running into trouble here because my y-axis does not show enough of the graph. So what I can do is I can use this unit point here to adjust my scale, and you'll notice that as I show more of the y-axis there, my points will stick to their coordinates. Okay, so these are still at the correct coordinates. I can also adjust my x-axis. The sketch has been built so that we can adjust these axes separately, and that's called a rectangular grid. Okay, now if I'm graphing as part of a contextual problem, I want to make sure that students think about what they're graphing, and so I would ask them to label the axes, and we can use the text tool to do that in Sketchpad. So I'm going to actually make a text box, and for my x-axis, I'm going to say raw popcorn, and for my y-axis, unfortunately, I can't make my text go vertical. I just need to write it horizontally. Maybe a feature for Sketchpad 5.1 can be to rotate this text. Okay, so I've got my axes labeled, and I have my data graphed. And now I might want to think about the pattern these points make, and students might observe that they seem to lie on a straight line. And we can check that out by using the line tool. And I'm going to connect 2 of my data points. And I can see that that line seems to go through all 4. Okay, so they do form a linear pattern. Now, I also noticed that the line goes through the origin, goes through the point 0, 0. So one thing I'd want to ask the students is, does it make sense for us to include 0, 0 as one of our data points? Because it's not in our table here, but does it make sense for the problem? And we could talk about that. If you have 0 cups of popcorn kernels of raw popcorn, then I think it's fair to say that you could make 0 popcorn balls. So I'm actually going to make that point larger to reflect the fact that it's one of our data points. And then we might want to talk about what's going on down here, and does it make sense to have any points in this quadrant of the graph where the number of cups of raw popcorn would be negative, and probably we could agree that that wouldn't make sense. So we're going to focus on this part of the model. Okay, so returning to the original question, how many cups of raw popcorn do you need to make 10 popcorn balls? Okay, well, I can use these guidelines here, 10 popcorn balls. That would correspond to 10 on the y-axis, because that's the number of popcorn balls. And if I have 10 popcorn balls, I can see where that intersects my model there, and I can get an estimate for how many cups of popcorn. Now, that's falling between, here's 1, 2, 3. This is falling at about 2.5. So again, I might want to ask students, does it make sense to have 2.5 cups of raw popcorn? Sure, I think I can have 2.5 cups of raw popcorn. I can't really have a half a kernel. If I start splitting kernels in half, that's getting a little unrealistic. But I can have a half a cup of kernel, so that could be a realistic answer. I can use this same method to extrapolate to how many cups of raw popcorn I need to make 20. But students might say, well, if I need 2.5 cups of raw popcorn to make 10, then I'm going to need twice as many cups of raw popcorn to make 20. So they could use some proportional reasoning there. And then we can check out that hypothesis using our guides and say, sure enough, it takes twice as many, so 5 cups of raw popcorn to make 20 popcorn balls. Now, here's the nice thing about this activity. I was talking about popcorn balls here, but you could really use this activity for any kind of data. And recipes are nice because it's easy to come up with a scenario in which you would want to make more popcorn balls or more cookies, more brownies. I guess I have a sweet tooth. So in that case, you're going to need to double the amounts of things, right? Or maybe you need to make 3 times as many. So it's a nice way to integrate proportions into your curriculum. And on the student worksheet for this activity, I'm bringing in the worksheet, it's pretty generic. So you don't have to use popcorn balls. You can use whatever data students are interested in. And once they fill out their table, they can use this graph to ask and answer questions. Okay, and I think I am going to stop for a second, see if there's any questions. Yeah.
We did have a question about how you got the 2 grid lines, the guidelines, the red dash lines. How did you create those?
Yeah, that's a great question. So I'm going to, in answering that question, I'm going to show you a tool that Sketchpad 5 has. And this eye here can give you information about any object in a sketch. And so if I click on one of my guidelines there, you'll see the question mark come up. It says line 1, which is this line, is parallel to axis Y passing through point 2. So point 2 is a hidden point, but this tells me that this guideline was constructed by creating a line parallel to the y-axis. So I'm just going to go ahead and show how you do that construction. If I take any point, construct any point, and I select my y-axis, I can construct a parallel line through that point. Okay, now this is a big fat line, but I can change it to be thin and dashed. And now when I move this line, no matter what I do to it, it will stay parallel. So that's what this guideline is. And then we can just hide this point, make it a little neater. Okay? And you can follow the same procedure to create the other guideline, except for this one. is going to be parallel to the x-axis. Okay? So those are just handy-dandy parallel guidelines. Okay.
And Elizabeth, the worksheet that you just referenced, will that be part of the materials?
Yes. Yeah, I will provide the student worksheet and the teacher notes for this activity with all of the webinar materials. Okay, other questions?
No, that's it. Great, thank you.
Okay, all right. I love questions, so please keep them coming. All right, so we're going to move on to a different activity, also building up concepts of proportionality and slope. And this one is called Reach the Target. Okay. Again, we're in a coordinate axis system. Oh, and before I get started on this one, I think I'm going to take this moment to give a couple interactive whiteboard tips. So I gave a workshop recently, and we were working up on a smart board, and we realized that this grid was very hard to see on the whiteboard. So I just wanted to show people that you can select the grid, and you can change the color just the way you could change the color of a line. You could pick something a little bit darker if you want it to show up better. It might be the same on a, I don't know, that might be a little too bright. It might be the same on a projector that you want a little bit of a darker grid. So you can change it to a darker gray, something that will show up, have a little bit more contrast against the white background. And the other whiteboard tip that I wanted to give is these axes numbers are pretty small. If you select the axis, you can, I don't know if everybody can see this, this is the text palette. I can actually change the font. And now you can see that the numbers on the axis are larger and easier to read. So I can do the same thing on the other axis. So I'm going to change these both to 16. Okay, so it's kind of a nice tip if you're presenting in front of the class. You might want to make the grid darker or the numbers larger. Okay, now let's get on to the activity. So in this, yeah.
I was just going to say, also on the color choices, beyond the ones that are the default ones, you can also choose other, and that's and so you can get a darker gray. In case you think black is too dark and the default gray is too light, you can choose other and then have access to a whole array of colors.
Yeah, and I do use that. If you go to other, you can choose from a variety of ways to pick the color. I tend to go with this one for some reason, but this one is kind of nice too. Sometimes you want to pick white for some reason. You know, white is a nice color to use sometimes, so depending on what you're doing. So the color palette, yeah, you have all of these choices. Okay, thanks, Andres. All right, so if I press my take a step button here, let's see what happens. Just check out what this sketch does. Okay, so one step corresponds to stepping vertically 1 here and stepping horizontally 1. And our goal here is to hit the target. And I'm going to see if we can hit the target just the way it is right now. Okay, we got it. So my question to students and my question to you is, can you tell me another way to hit the target? And students would need to come up with several ways, but if you can each just, or a couple of you can send me another way that I could hit the target by changing these numbers. Change these numbers to hit the target another way. Okay. Go up 6 and over 6. Oh, I love that 2 of you said that right away because that was my reaction too. I would rather just take one big step up 6, over 6. Boom, we got it. Okay, what's another way to hit the target besides up 6 and over 6, and besides up 6 and up 1 and over 1? I want one more solution. Up 2 and over 2. Great. Okay, so next question for students would be, you've come up with a number of ways to get to the target. What do all of your solutions have in common? And we'd want students to generalize, say what all of their solutions have in common. And Deirdre has a solution there. As long as they are equal, and both less than or equal to 6, it should hit the target. So in other words, we want our vertical step and our horizontal step to be equal and less than 6, because let's see what happens if we set them to 7. Yeah, missed it. So we need them to be less than or equal to 6 and equal to each other. Great, and we'd be aiming for students to come up with that kind of general rule. Now, what if we change our target? And I'm going to come up with a toughie here. And I'm dragging it over to the point 15.6. And don't put anything in the chat panel yet. What I'd like to do is I'd like you all to think of 2 ways to hit the target. And in thinking about how to hit the target, what kind of math knowledge and math skills are you using? So think about those 2 things for a second. 2 ways to hit the target, and what math knowledge are you using when you come up with, maybe when you come up with your second way to hit the target? Okay. Oh, and I'm going to change this from back to 1, 1 for a second. Ooh. Okay, so can someone tell me one way to hit the target? Comment? Okay. So give me a tangible answer. What should I make vertical and horizontal to hit the target? Up to and right 5. Okay, so let's try that out. Okay, got it. Awesome. So, oh, good. A lot of you came up with that answer. So part 2 of that question is what math knowledge or math skills were you using when you came up with that answer? And I saw someone had already responded. Common factors. So that's one way to figure it out is think of common factors of 6 and 15. Okay, any other? Both are divisible by 3. Okay. Any other math thinking that went into your solution? I think my way was to divide both by 3 using that common factor. Some of you may have thought of kind of equal proportions. That would be another way. So you can see, for some targets, it's a little trickier to come up with more than one answer. And in fact, if I reset to, say, the point 9.5, I think we might be hard-pressed to come up with 2 answers that both involve integers. Students might start getting into fractions at that point, or you might want to talk about mutual primes. Okay, so once students have kind of gotten the hang of this, you can move on to a more difficult target and start talking about negative steps. So I think, what's nice about this environment is we can experiment a little, and nothing terrible will happen if we do something that doesn't quite get us to the target. Oops. Okay, I can kind of see that I'm heading in the wrong direction there. So I might decide that perhaps I don't want both values to be negative. Okay, and students can experiment with this. And of course, for each target, they're going to try to find more than one way to reach it. And that's not going to work either. So can someone give me an answer for this one? Let's see. Maybe I can figure it out. This proportions both are divisible. Let's see. So for the target of negative 6.4, what would be a step that would work here, vertical and horizontal? Up to left 3. Let's see. And I'm just typing these numbers in. Let's try it out. Excellent. Okay, so a couple things about this activity. It's a nice time to practice some vocabulary like vertical and horizontal. You might talk about X coordinate and Y coordinate. And you might also start introducing the terms rise and run, getting students, if those are the terms you use when you're introducing slope, you can start using those now. Talk about the rise of each step and the run. So there's a nice kind of extension to this activity, and you'll be getting this with your materials from the webinar, and that is after students are really good at these target practice exercises, you now get a start that is not at the origin, and now students have to start thinking about the vertical distance from, not from 0, 0, but from another start point. So what's the vertical change here, and what's the horizontal change? And then they're really developing the idea of slope. Okay, so questions before we continue on? Can you go from target to start? You would need to do a little redesign of the sketch, but yes, I'm quite sure that we could figure out a way to go from target to start. There's actually a few different Explore More pages, and there are probably some where there's a, a negative slope. So I believe there are, but that's a great question. I really recommend to all of you that anytime you have an activity that you like and you want to extend it, just start tinkering around with the sketch, and you'll learn a lot about Sketchpad, and you can really customize activities to make them work for you. If you go without resetting, will it just go on? Yeah, that's a good question. Let's see. I think so. Yeah, it'll just keep going after the target, I think. Let's check. Yep. Okay, so you do need to press reset to clear it and start over at the start. Okay, any other questions about this activity or anything?
No, you managed to read them before I could say them out loud, so
oh, okay.
I think we're good.
Okay. All right. Okay, next up, one of my favorite activities for this this level, and I want to introduce to you Mellow Yellow. This is Mellow Yellow, and Mellow Yellow is going to be walking from home to the corner store, and this graph represents her travels. Okay, and so let's just watch and see what happens. Okay, so you can see there's two different graphs here of Mellow Yellow's trip. Okay, so you might want to show it to students several times so they can kind of keep an eye on both graphs and understand what's going on. And then you might have them talk about what they noticed, that Mellow Yellow stopped here, but on this graph, something is still moving. And I'm going to show the story. And the story says that Mellow Yellow decided to walk to the corner store, which is less than a mile away. Okay, so looking at the graph, the corner store corresponds to this stop point, which is indeed looks like just under a mile away from the start point. This is the distance. She got about halfway there and stopped to rest a while and then started walking again, but faster than before to make up for lost time. So we might want to watch the graph again and kind of observe that as she stopped resting, she's sitting there on this graph, but this keeps going. And that's a good time to talk with students about what this graph shows, because from this time, about 5 minutes, to this time, about 10 minutes, time doesn't stop. It keeps passing, and about 5 minutes pass, but her distance from home does not increase because she's stopped. She's resting. Okay, and in doing this kind of graph interpretation, I'd like to hear from you in the chat panel. What kinds of misconceptions do students have? What kind of confusion would they have in interpreting a graph like this? And if you can let me know in the chat panel what kinds of, yeah, I think she's walking uphill. So one, I think, common interpretation is to see this graph as being a picture of Mellow Yellow's route. So she's going uphill, she's walking on a flat surface, and she's walking up a hill again. And so we really need to look at the axes and say, okay, here's time is passing, and here's distance. And maybe look at each point individually and talk about what it means in terms of Mellow Yellow's trip. They said the flat part was going the same speed. And so, Raylyn, I'm curious if you have were you able to address that with students? Were you able to sort of get past that misconception? Tell them to look at the axes. Okay. Yeah, so again, one thing you might want to talk about is what does this point mean in the trip? That means that 5 minutes she was at about 4/10 of a mile from home, and after 10 minutes, she was about 4/10 of a mile from home. So she really didn't move at all away from home during that 5 minutes. Okay, so this is story 1. And story 2, we have the story. Mellow Yellow started walking to the corner store, turned around halfway when she realized she had dropped her hat. So now we're introducing something new because this is going downhill, and let's see what that means in terms of Mellow Yellow's walk. Okay, so she's walking to the corner store. Whoa, okay, so this shows her changing direction and then running to the corner store. And again, students may be confused. They may think she's going uphill and then downhill, so you really need to talk about what the points on the graph mean. Her distance is getting smaller from home, but time is still marching on. This whole time we cannot go backwards in time, okay? So the graph keeps on moving to the right. The next part of the activity, and I think you could spend quite a long time on this part of the activity actually. The next part of the activity asks students to adjust this graph to match the story. So in other words, these points can be moved, and we want to move them so that they're going to match this story, walking very slowly to the corner store. So in order to walk very slowly, we're going to need to think about the fact that over, say, 5 minutes, Mellow Yellow is not going to get very far at all. So her distance from start isn't going to be very far at all. And then again, we have to address this idea of resting, and that means that she won't travel any distance at all. And then she's going to run. Okay, now I have her running very fast. And now we can check and see how well I did here. She's going very slowly, not moving. Zoom. Okay, so I really have her sprinting probably at a record-setting pace, so that might not be very realistic. But, you know, students can have fun with that, make her zoom along. Okay, so I do want to point out that there's a bit of a simplification in this model, and it kind of has to do with what I was just talking about. So in terms of this model, what is it ignoring, or what is it simplifying in terms of Mellow Yellow's pace? If you can put an answer in the chat panel. What's a bit of a simplification in this graph? Oh, there's a lot of tricky construction questions going on. Oh. So again, oh, my question is, what about this model is a bit unrealistic? And in particular, you might comment on the way that I just arranged the graph. What's a little bit unrealistic about this model? Yeah, it could be that she could run that fast. I may have, we might want to talk about whether in 1 minute she could run almost an entire mile. That certainly seems unrealistic. I think I need to give a little hint. Another thing, okay, yeah. So Denise and Jean, I was being a little bit cryptic there. They've hit on my point, which is that this is saying that instantaneously mellow yellow is going this quickly. And in reality, aside from the fact that she probably can't run that fast, she'll need time to get from a resting position to a full-on run. So probably a more realistic graph would have some curves in it, right, to show that she has to accelerate to get up to a speed. That's okay. You know, you can discuss that with students. You might want to. Someone may ask you about it. Someone may not. But just know this is a model, and it doesn't cover every nuance of the situation, and that's okay. Last one, we have a graph, and students write a story to match the graph, and they can get as creative as they want to about the reasons for mellow yellow having to stop, rush, and stop again on her way to the corner store. Okay, so I saw that there were some questions. I wanted to check in and see if there's, Raylan said she has to have really good tennis shoes to be able to launch into that speed. True. Or maybe someone's coming by on a scooter and she just hops on and the scooter's already going that speed. You can think of some scenarios in which she might not really have to accelerate, but so you just have to start getting pretty fancy with your stories. Okay, any questions?
So a couple of people, Sanjita and Piyush, have both been asking about how this sketch was made and how the story came about and so forth. I mean, I'll let you say more, but I do want people to realize that this sketch, in fact, it was developed by us using Sketchpad, but it's a very sophisticated sketch. It's not something that when you first learn how to use Sketchpad, you would just be able to create this with just a couple of tips.
Right.
I made the point about, I wrote in a note about the hide show button, that was the way you made the story come up.
Right.
This one doesn't have a hide show button because there's no story written, but on a different page,
right.
You know, that has.
So if I want to hide a story, I can, I'm on edit now, I can create an action button, and I can name this anything I want. I'm going to call it hide story, and you can do this with any object, whether it's text or a circle or a point. You can, if you don't want to hide it for eternity, you can just create a hide show button. And so that part of the sketch, I think, is as easy as that, is creating a button. But Andres is right. I don't
Why don't
know
you show
the details of how it was constructed. Should I show all?
Show all hidden.
Ooh. Okay. So when you're really curious about a neat sketch and you want to just get a sense of the complexity, one thing you can do is to show all hidden, and this will show all the objects that were used to construct the sketch. So you can see there's a lot of heavy-duty math going on here, calculating differences in distances, time, distance. There's a lot of different parameters here. So yeah, this is a really complicated sketch, and so I'm going to hide those. Thankfully, we can use the sketch without having to know exactly how it works. That is the beauty of these pre-made sketches. And what's really nice, what I particularly like about this one, is the sketch itself seems very simple. It's very easy to use. It's just pressing a button. It's, you know, you can change points in a sketch, and it's very satisfying to see that that actually changes the speed of and the path of mellow yellow. So it's not difficult to use, but it would be difficult to make this sketch from scratch. Ooh, scary. Okay, so yeah, and I have to say, in terms of the activities today, the first sketch we used was really just a grid, and with these guidelines added in. The second sketch, I don't think this one is very complicated to make, but this mellow yellow sketch is pretty complicated. And that's fine because I think they're all nice to use. Okay, other questions? Oh, yeah.
Go ahead.
Yeah, if my screen is looking a little bit jerky or jittery, that is go-to training. It's very smooth. If you look at you'll get the sketch as part of the materials, and mellow yellow will move very smoothly. Okay, anyone else? All right, so for the last activity, I'm going to show one that is absolutely easy to do from scratch, and it's actually just a game for students, and students can do it probably without much help from you. Okay, starts in a blank sketch, and you're going to be using the line tool to construct a bunch of lines. Oops. I think I want to make them solid, and once I set this line style, it will stick for the next lines that I make. I'm going to make 5 of them, and I am not connecting any of these lines. They're all independent. Okay, and then I'm going to measure the slopes. So I'm selecting all my lines, and then I can measure all of the slopes at once. Now, when I measure the slopes, the coordinate grid automatically appears because you can't really have a slope measurement unless you have a scale of a grid. Okay, and as I measured the slopes, all of the points also got labeled. So now I can identify which line is KL, which line is MN, etc. Okay, now this is going to be a matching game, and to make it a little harder to match them, what I want to do is hide the labels. And I'm going to show you a neat shortcut, which is if you select the point tool here and then go to the display menu. Oops, maybe that's not going to work. Let's try again. So go to the point menu. Oh, here we go. Go to the edit menu. I can select all points, and because I have the point tool selected, this option comes up. So now all the points are selected, and now I'm going to make an action button to hide all those points. Okay, so again, using the hide show button. Okay. Okay, now with those points hidden, I really don't know which line is which. So at this point, I would hand my sketch over to a partner and say, okay, match them up. Drag each label to the line that has that slope. And now students have to figure out, oh my gosh, okay, which line has a slope of about +1, which line has a slope of about 0.5, etc. You can set these preferences to be 1 decimal point if you want instead of hundredths. Okay, and so the challenge is for the partner to match them up, to drag each slope measurement to the correct line, and when they've finished, you can check their answers by pressing the show points button. I'm not going to do all of them right now, I don't think. Well, maybe I will. Let's see. Something like that. Okay, and then you can check by doing show points, and I can see if this is my slopes match my line, and then the partners can switch, and the other person can mix them up and hide the point and start over. Now, one way that you can mix them up is, I will show you one last trick here because it's kind of fun. I can drag the lines individually to mix up the slope, or I can select them all and just scramble them randomly. So if I do that, selecting all the lines, and I can actually create a button. I can animate, and I'm just going to do them all randomly at, maybe I'll do some fast just to make it more random. Okay, and now if I press my Animate Lines button, it's going to mix up all the slopes automatically. And then I can hide the point, and I really think kids would love this. And now my partner's ready to play the guessing game. Now, when kids do this, if they want to be mean, they'll make the lines really, really, really flat or really, really, really steep, really, really similar slopes so that it's hard to figure out how to match them up. But if you do it randomly, actually, this looks, other than this one, it looks pretty hard. Okay, so that's the slope game. And again, I just made that from scratch in about, a couple of minutes, and students can do it easily. I'll give you the instructions for that so that you can try it with your students. Okay, so questions? Yeah, for this.
Yeah, that was.
Go ahead.
You're about to answer a question.
Well, in terms of showing the slopes as fractions, there is a tool to do that, but for this activity, I don't have an easy way to show them as fractions. When you're just measuring slope, the default is decimal. So yeah, students do have to get accustomed to working with the decimal slope.
Yeah, I was going to say that fractions is kind of is a little bit artificial sometimes too, because here you have a continuous range of possible slopes, not just the ones that break down to nice fractions that we generally work with. It's not. I mean, you can go to 4/5, but what if it's just slightly more than that? Well, are you going to say 81/100ths or whatever? So decimals is, because of the continuous nature of measuring the slope, a fraction doesn't really work so well.
Yeah.
I mean, they're not.
Yeah, it's true. We had a suggestion that if you did snap points, that you might get kind of nicer values for your slopes, and I think that's probably true. If I set it to snap points, then
well, then you have clean integer rise and runs, right?
Yeah. Of course, you could still end up with something like 3/7, right? So.
Well, which is still a nice fraction, right? But
in terms of the decimal values, doesn't make that much of a difference. So yeah, you can snap the points and create the lines, and that might make it a little friendlier. But you can sort of see the values down here. You'll still have decimals. Your students are still going to have to deal with decimal.
So when you get started again, I'll look into Ed's request for slopes as fractions. A question came earlier, I don't know if it's a little too disruptive, from Michael about infinitesimal steps. I think that was on the reach target. Are you limited to?
Oh, to like integer steps, or can we do small steps?
Yeah, like infinitesimal.
That's a great question.
I mean, you can go smaller. And are you able to?
Let's see. Let's see. Yeah, I know in the activity they ask for integer steps, but let's see if you wanted to talk about limits or something. Let's see.
Yeah.
Ooh, look. Can you see it? It's barely moving.
Yeah, it'll take you 100 clicks to get just.
I'm clicking it a lot now. Oh, that's a great question. So yes, you can probably. I mean, you're limited down to the pixel. It can't go any smaller than that, but this could be an interesting way to talk about, I don't know, maybe to talk about limits. I don't know what you're thinking, but kind of a neat idea. Because now I'm basically coming up with a straight line. You can't really see the steps. So that's pretty neat. Good idea. Neat. That would be a neat extension, I think. Okay, other questions?
No. No.
Okay. So I want to talk about some resources, and then we'll see where we are in time. I think we're about getting ready to finish up. So this will come on your on the sketch that you receive as part of the webinar materials. Links for where you can download Sketchpad. You can download a trial copy, and you can run it for 20 minutes. So for those of you that are new to Sketchpad 5, you can see what it's like. Just download it. You can play with it for 20 minutes. If you want to register it, just need to pay for it, and we'll send you a registration code. And when you're in Sketchpad 5, even when you're in the trial version, you'll have access to the Learning Center, and you can see, Okay, let's see if I can get that to come up. When you're in the, this is, sorry, I'll show that again because that was kind of fast. In the Help menu of Sketchpad, you just select Learning Center, and that will bring you to Learning Center, which includes tutorials, great for learning about Sketchpad, and sample activities. And some of the activities we did today, like Mellow Yellow, that's a sample activity that comes with Sketchpad 5. The slope game is an algebra activity that comes with Sketchpad 5. Points lining up in the plane, I didn't have time to do that today, but this is another really nice activity that builds the foundation for slope and graphing. So just wanted to point out the Learning Center for those of you who are not familiar with Sketchpad 5. Two of the activities that we looked at today came from a middle school module called Exploring Ratio, Proportion, and Probability. So this is middle school activities, comes with a student worksheet, the teacher notes, and sketches. And so the first two activities that we did today, the Reaching the Target and the Graphing the Popcorn Balls, those activities came from this module. I wanted to make sure to let people know we're starting a new series of online courses October 3rd, and the registration deadline is next Thursday, September 29th. We'll have teaching middle school with Sketchpad, teaching algebra, teaching geometry with Sketchpad. We also have courses for Tinkerplots and Fathom. So really encourage you to sign up for those courses if you're interested in getting a more in-depth understanding of Sketchpad. And you get a lot of great activities with the course, and the facilitators just are extremely knowledgeable and have experience using Sketchpad with their students. So I really recommend those. And lastly, we have a community site where you can share sketches, and you don't have to do anything. You can just browse through, and anything that looks interesting you can download. You can search by level, you can search by keyword. We now have some of the sketches tagged iPad because they are nice to use with the new iPad app, Sketchpad Explorer. And if you go to the community tab, we have forums where you can ask questions about constructions, learn about the new iPad app, learn about webinars, and ask just general questions. So I wanted to share those resources, and those links are all in the sketch. Okay, so questions?
So Elizabeth, I just had a thought on the fractions. I mean, the one thing that the slope you could do is create your own slope tool rather than measuring slope directly as a measurement.
Yeah.
In which case you could then measure the rise and measure the run, and then you get you could display it as a fraction. Although
yeah, I think that's the way it works. Yeah.
And the numerator and denominator will not necessarily be integers then, though. Although they would be if you were in a snap to environment.
Right. I believe I'm thinking that of a particular activity that I think had a slope tool like that, and so I can try to dig it up and send it with the materials if that makes sense. I will try to find it. I know I've seen it before, but apparently it's not that easy to find. So I'll look for that.
Okay.
All right. Other questions?
Well, a comment that on a Mac it's different than Windows. There are they look a little different because of the built-in operating system functionality that's drawn from, but they really are identical. There'll be small differences, like for example, where the text palette shows up in Windows will be different than Mac. The thing that Elizabeth's dragging around right now will often be at the bottom of the window, and it's usually docked, while in a Mac it'll be floating free. But they're
the keyboard commands, control instead of the command. That's always the case between Windows and Mac.
But there shouldn't be any other differences. There's sometimes also a difference in terms of how many pixels are defined to be 1 centimeter. But those are platform-specific conventions. But for 99% of what you're doing, it shouldn't make a difference at all when you're which platform you're using.
Yeah, it's really similar. What Andres mentioned, the difference in measurement, that can make a difference if you create a sketch, say, on a Macintosh, and then you use it on a Windows machine, and you did all your measuring in centimeters. You might see a change in the measures when you move from Mac to Windows. That's the one difference that I've noticed. But other than that, yeah, it's just mostly where the text, how you see the text palette, and which key you use to do the keyboard command.
Okay, well, it's just after 5. I don't see any other questions, so I want to thank you, Elizabeth, for today's presentation, and I want to thank all of you for joining us for today's webinar. And you will, when you leave the webinar in just a moment, you'll receive a brief survey, which we would really appreciate if you would fill out. That's how we get feedback, so that we can continually improve our webinar presentations. You'll be receiving an email with your certificate of participation and directions for getting your zip file. And again, thank you for spending this evening with us, and thank you, Elizabeth, for a great presentation, and we hope that you will continue to come back to Key Curriculum Press. Again, every Tuesday we'll have a webinar, and we encourage you to look into all of the things that we have to offer through our website, including online professional development courses and other software as well. So after that, we'll say good evening and thank you for joining us today.
Yeah, thank you, Andres. And thanks, Karen, for answering questions.
We'll leave the chat open for another minute or so, and then I'm going to end the webinar. Thanks again.